5.3, solving parts of triangles. Objective. Given two triangles, students will determine whether they are congruent and use that to find missing angles and measures. Okay, so we learned about how to find whether triangles are congruent on the last video, but let's talk about a couple key things, some key definitions. Some of these are things you're already familiar with. Equilateral. Equilateral means that all the sides are equal, or they're all congruent. It also means that all the angles are congruent. We'll talk about that later, but all the angles are going to be congruent as well. Isosceles. At least two of the sides are, we'll say, congruent. And here we should have said equal or congruent. Either one would be fine. Okay, so we got equilateral, all of the sides are congruent. Isosceles, at least two of the sides are congruent. That means that an equilateral triangle is also an isosceles. Isosceles may not necessarily be equilateral because equilateral has to have all three, but every equilateral is definitely an isosceles because it has at least two that are congruent. Scalene, what do we mean by scalene? All of the sides are not congruent. That means none of them match. They're all different sides. Acute angles, this means that all the angles are acute or less than 90. Right angle means that one angle is right or 90 degrees. And lastly, an obtuse angle triangle, this means that one angle is obtuse or greater than 90 degrees. All right, so that's just some basic definition. Now let's go talk about some example problems. Example number 1 says, ABC to the left is an equilateral triangle. If AC, so if this distance here, AC equals x plus 9, and we could actually, if we wanted to, we could write that in. So this is x plus 9. And BC is 3x minus 9. And AB equals 2x. Looks like the C kind of got cut off down here, but that should be C. Find x. Well, if it's equilateral, we can set any two of these sides together and solve. We don't need all three sides. We only need two. So I'm going to pick these two because it looks like the easiest two to set equal. So I'm going to say that AC is equal to AB. Plug in AC is x plus 9 and AB is 2x. And let's just do this algebra real quick. Let's subtract x. I get that 9 equals x. There we go. Boom. We've solved it, right? So equilateral means all the sides are equal, so we can set them equal to each other, right? So for practice number 1, it's a very similar problem. It says using the same picture but with different measurements. So same picture, but now you might want to delete those measurements or erase those measurements. Find y. So they tell you that AC is y plus 3, BC is 2y minus 4, and AB is 3z plus 1. So the challenge here would be to find z as well as y. So y should be easy, but then once you find y, can you find z? I'm going to let you guys go ahead and try that one on your own, so you may want to pause the video, give it a shot, and then I'll be back with the answers. Okay, so all we have to do is set the two sides equal to each other that both have a y in it. If we do that, we get y plus 3 equals 2y minus 4. Do some algebra, we get that y equals 7. And that makes sense. If we plug it back in, 7 plus 3 is 10. 2 times 7 is 14. Minus 4 is also 10. So we know that all these sides are 10 because it's an equilateral triangle. Well, that means that AB, this side with the z, is also 10. So we can say that 10 equals 3z plus 1. And we could solve for z as well. Subtract 1, 9 equals 3z. And I'm running out of room, but divide both sides by 3. And you get that z equals 3. Sorry, I got a little messy there. But yeah, z would have to be 3 then, right? So you found y and z. No problem. All right, let's talk about an isosceles triangle. Definitions of isosceles triangle. First of all, the legs. These are the congruent sides of an isosceles triangle. So we call these the legs. And the third side we call the base. So the base is the unique side and the legs are the congruent side. Next one is the angle formed by the two congruent sides. This is called the vertex angle. Vertex angle, remember again, that's the one in between the two legs. And then lastly, the angles opposite the two congruent sides. These two angles, if you start at the leg, go opposite, start at the leg, go opposite. These are the base angles. Okay, that's just some terminology that we're going to need, some vocabulary that we're going to need. So let's go on to the next page. So we need that vocabulary because there's a couple theorems about isosceles triangles that are going to make it real handy for us. First theory is if two sides of a triangle are congruent, I'm just going to write the congruent side, right? Then that means they're isosceles. Then the angles opposite those sides are congruent. Okay? So let me just kind of draw a picture for you. Let's say we have some isosceles triangle here where these two sides are the same. If we have these two sides are the same, then we can go ahead and assume that these two angles are the same as well, because they're the ones opposite these sides. Imagine that the little hash mark is like a cannon. Boom, it's going to point right at the opposite angle. Boom, right at the opposite angle. Okay? The converse of that is just the kind of the reversed. And the reverse says if two angles of a triangle are congruent, then the sides opposite the angles are congruent. So if you don't know the sides are congruent, but you know the angles are, then that means the sides have to be congruent. So you can flip it. All right. That's good. That's the isosceles triangle theorem and its converse. But now let's get a little bit more specific. The next one is called the vertex angle bisector theorem. All right. Well, what does it say? The bisector of the vertex angle, and again, bisector just means something that cuts it in half. So the line segment that cuts this vertex angle in half, the bisector of this angle of an isosceles triangle, is the perpendicular bisector of the base. So that means it's going to cut this base into two congruent halves, and it's going to be perpendicular, so it's going to be exactly a right angle right there. That's kind of a nice little feature. So that means we can know quite a bit. If we know that this angle is cut in half, then we know a lot about this side and these angles. We know a lot of information in an isosceles triangle really easily. Okay, well, let's use that in this example. It says find the measure of angle D. Well, one thing that I know here is that this is an isosceles triangle because these two sides are marked as congruent. Well, we learned that that means that these two angles are congruent. Now, there's a few ways you could figure out this problem. Lots of different ways, but if we use this theorem right above, the vertex angle bisector theorem, that means that we could draw a vertex angle right in that bisects this 133 degree angle. Well, 133 divided by 2, if we cut that directly in half, that's 66.5. And we just learned that if we cut this into two congruent halves, so if this half equals this half, then that means, and I need to do some type of alternate marker here so that we don't confuse it with this angle here, then that means that this has to be a right angle here. So now we know that this angle is 66.5, this angle is 90, and so we can very easily figure out what angle D is here, which is what they're asking us to do. So, well, we could do that pretty easily. We got angle D plus the 90 from the right angle plus the 66.5. All that is still a small right triangle, so it has to add up to 180 degrees. So just do a little bit of algebra, and we get that angle D plus 156.5 equals 180. Subtract that from both sides, and you get that angle D is equal to 23.5 degrees. And there's how we found angle D. Now, that's not the only way to do it. There is another way. Let me show you that real quick. Before you did all this angle bisector stuff, you could have said, you know what, let's just call this X. And let's call this angle X because they're the same angle. and we have this third angle, 133. We could have said, hey, you know what? X plus 133 has to equal 180, and we could just solve for x. We get 2x plus 133 equals 180. Subtract 133 from both sides, and you get that 2x equals 47. Divide both sides by 2, and you get that x equals 23.5, which is the same thing we got before. Okay, so a couple different ways to solve a problem like that, but we're basically using our properties of isosceles triangles that we learned about here. Okay, before we continue, I just want to take this time to let you know that if you want full credit on these notes, you're going to want to put your favorite band name right over here next to example 1. Okay, let's keep going. Define a couple terms. Next term is a corollary. And a corollary is basically a statement that follows immediately from a theorem, like a spin-off of a theorem, okay? Some like kind of a side theorem, I guess you could say. And so a corollary to the theorem above is that if a triangle is equilateral, right, which means all the sides are the same, then the triangle is also equiangular. And that's what I said at the beginning, that all the angles would be the same. And since they're all the same, we know that they all have to add up to 180, and 180 divided by 3 is always going to be 60. So an equilateral triangle always has 60-degree angles every time. And the converse to that is that if a triangle is equiangular, meaning we only know that its angles are all equal, then the triangle is equilateral. That's enough to say that all the sides are congruent. All right, let's go on to the next page. Okay, so let's take a look at triangle DEF here. It says that it's equilateral, so that means that DE is congruent to EF. And even though it's not marked, that means that DF is also congruent to these two. So the first thing they want us to do is find the angle DFE. Well, DFE is just a normal angle of this triangle, and they said it's equilateral, and we know that all equilateral angles are all 60. So all three of these angles here are 60 degrees. So that's easy. You could just say it's 60 degrees. Then for the next step, they say the measurement of FDE equals 15x. Find x. Well, FDE is another angle of the equilateral triangle, so we know that it equals 60, and it also equals 15x, so this is actually pretty easy to solve for x. Just simply divide both sides by 15, and you get x equals 4. And so that one's done. Now for the last one, I want you to try and think about this for a second. It says find the measure of DEG, or if measure of DEG equals 8y minus 4, find y. DEG is this angle right here. These little markings say that these two angles are congruent. So you should know what this whole angle adds up to, and then you should be able to figure out what these two angles have to be, and therefore solve for y. So I want to let you guys go ahead and try that on your own, and then pause the video while you try it, and then check back in a second or two, and I'll have the answer for you. Okay, so the trick here is to know that all these angles are 60, and if these two are two congruent parts, then what we have here is an angle bisector. So these must each be 30. So it's 30 degrees. Angle DEG equals 30, so we can say DEG is 30, which equals 8y minus 4. Do some algebra, and we get that y has to be 17/4. Now I know that's not really a pretty number. If we were to write it as an improper, or I'm sorry, as a mixed number, it would be 4 1/4. That's okay. Just because it's a fraction doesn't mean it's wrong. That's actually the correct answer, and so we've solved for y now. All right. Last step says if you can classify triangles by both their angles and their sides, for example, right isosceles, then how many different angle-side combinations can you come up with? List as many as you can and try to sketch out what they would look like. So right isosceles is 1, try and think of some other ways that you can name it, and that's the descriptions that we found on the first page. So think of all the different names you could come up with and make sure that they actually are possible, right? So you might want to sketch them out to make sure they're actually possible. Oh, and the other thing I'd say is this description, it has to do with angles, and this has to do with sides, right? So we did an angle and a side description. You're probably not going to do a side and a side or an angle and an angle. That wouldn't really make sense. So come up with as many as you can, and we'll talk about them in class. See you guys on the next video.